Okay, so we are going to take a look at how to solve an inequality. And the first thing we want to do is remember that we have to follow our rules, the same rules that we follow when we're solving an equation. So rule number one is to go ahead and to divide our problem in half by building a wall. Then we want to combine like terms on the left and on the right. These terms are obviously combined since this is just a one-step simple equation. We also want to ensure that our variable term is only on the left-hand side or on the right-hand side. In this case, we're on the left. The next thing we want to do is we want to follow SADMAP. SADMAP tells me to look for anything that's being subtracted or added to my variable term. And in this case, we do not have anything. Next, we want to look at, is there anything being multiplied or divided by our variable term? And in this case, where our x is being multiplied by a -4. So in order to simplify this and get x by itself, we have to use the identity property. And what we're going to do is we're going to divide both sides by -4. Now, when we do this, there's a simple rule in inequalities that whenever you multiply or divide by a negative number, this symbol in the middle is going to have to flip directions. So I'm going to take care of that right away so I don't forget. So instead of being greater than or equal to, this symbol is now going to become less than or equal to. And -4x divided by -4, -4 divided by -4 is 1. 1 times x is just x. And 32 divided by -4 has to follow our integer rules. So a positive divided by a negative is negative. 32 divided by 4 is 8. So the solution set to this equation, or I'm sorry, this inequality, is that x, or all values of x, must be less than or equal to -8. Now, if I were to graph this, we would create our number line here. And since we're going to be on the negative side, let's put 0 over here. So 0, -1, -2, -3, -4. Here's -5, -6, -7, -8, -9, and here's -10. So we are going to be at -8, and because this is less than or equal, meaning it could equal -8, I am going to use a closed dot, and we're looking at all the terms that are less than, so our arrow would be pointed to the left. So that is how we would graph our solution. Now we're going to try another example. And this example, you'll notice, does not have a negative coefficient. So we're following the same set of rules as we normally would. And we're going to build our wall. We're going to ensure that our variables on one side and combine like terms. And now what we're going to do is we're going to get into that division of 8 because we want to isolate the variable on the left-hand side. So 8 divided by 8 is 1, and 1 times x is x. 72 is negative, so negative divided by a positive is negative. 72 divided by 8 is 9. Now, you'll notice that this number is negative. However, the number that we are dividing by is not negative. So therefore, our symbol, our inequality symbol, stays the same because we did not divide or multiply by a negative number. Now let's graph our solution set. Here's my 0, -1, 2, 3, 4, -5, 6, 7, 8, 9, -10. And in this case, our x values are going to be greater than or equal to -9. So again, it could be equal, so I'm using a closed dot at -9, but we're looking at all of the terms that could be greater than -9. So our solution set would graph to the right.